Welcome to all my most esteemed mathletes. Today we are dealing with ratios, I guess? I'll have to look up and see what they're generally called, but we could definitely use ratios for some of these. Let's take a look at this top one. This top one says Perry traveled at an average speed of 55 miles per hour for 3.5 hours, and then traveled at an average speed of 60 miles per hour for 2.5 hours. What was the total distance in miles that Perry traveled during this time? So, right away I know I'm looking for what was the total distance in miles. And so this first pair up here, 55 miles per hour times 3.5 hours. If I want, I could just add this over and over, right? 55 the first hour, 55 the second hour, 55 the third hour, and then I have to do like half of that. And so since I got to do math anyway, repeated addition is the same as multiplication. So I'm going to take that 3.5 and just multiply it. Now, a couple things to note. I am not writing down the units, but if I did write down the units, it would make sense because miles per hour means miles divide by hour. That per literally means divide. And if I multiply that by hours, and let's say I treat hours like a fraction, put hours over 1, then when I multiply these units, I've got top times top, bottom times bottom, and I can also do this thing called cross-canceling. So hours cancels out hours, and the only thing left is miles, which is perfect because that's exactly the question I'm trying to answer. The other thing is that I set this up very intentionally with the 5, 5 on the bottom, even though generally we think, okay, you put the big number on top, you put the little number on bottom, 3.5 is little, it should go on the bottom. That was only because it was easier back in the good old days. Now we look at each one and we say, put the easy numbers on the bottom. And so if I have to multiply by 5 and then by 3, that's harder than if I just multiply by 5 and write it down again. So here 5 times 5 is 25, 20 up there, 5 down here. 5 times 3 is 15, plus 2 is 17. Just squeeze that in there. I used my ones place already, so I'm done with that place. Underneath this 5 I'm going to go, but I don't have to re-multiply. I know that 5 times that stuff up top, just like it was here, is going to be a 5, a 7, and a 1. I add all those things up, and I got 5 plus nothing, 5 plus 5, that's definitely a 7. I said 5, I meant 7. Carry the 1. 1 plus 7, 1 here. And if I wasn't sure, I could use my decimal rule, but what if I'm not even sure about the decimal rule? Well, think about this. If I go about 60 miles per hour for about 4 hours, it's going to be about 240. So where could I put this decimal that would be even close to 240? If I put it here, 1.9? No. 19 point something? No. 192? That's close enough. 1,925? No. So even logically, the only place I could put my decimal is right there. But we don't have to rely on sheer logic. We can also rely on logic practiced and taught over thousands of mathematical years by math teachers, I guess. I don't know the history of math. But the rule says the number of spaces after, aka to the right of the decimal place, in the top part, has to match the number to the right after. I got one up here, I need one down there, and either way, we get 192.5. Then I jump to this next one that says 60 miles per hour for 2.5 hours. Now this one's not bad to just add it up. 60 the first hour, 60 the second hour, half an hour is half of 60. I can add that up, no problem. If I'd rather multiply, then here I'm going to put this 60 on bottom because a 0 is super easy to multiply. And when I do that, I will get the same exact thing I would get if I were adding. 0 times everything is 0, done. 6 times 5 is 30, carry the 3. 6 times 2 is 12, plus 3 is 15. 1 to the right of the decimal here, 1 to the right of the decimal here, 150. Zeros, 12, 15, boom. I got to add 150 plus 192.5. Now already I know it can't be either of these because those don't have a 0.5 anywhere. And so really, once I add that ones place, it's either going to be a 7 or a 2, and I'm done. 150, 0 plus 2, boom, done. If you want to prove it, feel free to add the rest of those numbers, and you will find they are also 3 and 4. Number 9, aka the second problem on this page, says, the ratio of boys to girls in Miss Cunningham... Why would I write over the top of problem? Sorry about that, kids. Anyway, the ratio of boys to girls in Miss Cunningham's class. Oh, hello, Patrick. Oh, hi. What are you doing? Well, I'm trying to teach math, but you're a little bit in my way. Oh, I don't get it. Why don't you just stay there? Oh, stay right here? No, you were fine over there, and now you're in my way. Who are you? I'm a math teacher. Oh, who am I? You're Patrick Starr. Wait a minute. How did you know that? Well, because you're like a big TV star. Big? I'm not that big. I've been working out. No, I mean like you're famous. Fame us? You mean fame me? There's just one of me. All right. Have you seen SpongeBob anywhere? Well, sure. He's right up there. See him? No. This is not SpongeBob. This is SpongeBot. SpongeBob. SpongeBot. This is a robot that looks like SpongeBob that I use to hold my camera. It's not actually SpongeBob. It's a robot. See, you can turn his whole face like this. You think you know a guy, and then you find out this whole time he's been a robot. Okay, get out of here, Patrick. Shoo. Okay. Is mayonnaise an instrument? Go. Someday I will find out how to not have distractions in the middle of my lessons. In the meantime, we were doing something about math, I think, probably. At this point, I don't know. Oh yeah, this one. The ratio of boys to girls, we'll just go ahead and color code those right now, in Mrs. Cunningham's class is 3 to 2, which means every time I read that backwards, 2 to 3. Boys came first, 2 comes first. So every time I see 2 boys in the class, I see 3 girls in the class. They're written in that order, in the word part and in the number part. So that's how I know the picture looks like this. But I also know there's 18 girls in the class. So when it says, what's the total number of students in Mrs. Cunningham's class, I know that this is just a little picture. Maybe these are the study groups that she splits her class into. Maybe these are the ones who line up for recess together. I don't know. The point is that I have groups that all look like this, and I know that's true because of this word ratio. Ratio means the size of the group. And sometimes it's just one group, but I can see here if there's 18 girls, there's more than one group because I only have 3 in this group. And so what I can do is I can keep going until I get 18. So there's 3 girls, put 3 more girls, 3 more girls, and then I gotta count and keep track until I get to 18, which oddly enough for me is hard. A math teacher, I don't count well, because I know there's a much easier way to get from groups to total. I would just multiply. I know I'd need 6 of those groups that had 3 each to get a total of 18 girls. 1, 2, 3, 4, 5, 6 groups. Now, even if I didn't draw this picture, I would know that every one of these groups has 2 boys in it. And so the boys, there's also going to be 6 times as many, because I have 6 groups. But it doesn't ask me about the total number of boys. So what I really care about is the size of the whole group. I've got 5 people 1, 2, 3, 4, 5 in the whole group. And since I know from the girls' count that I need 6 of these groups, I'm just going to multiply 5 by 6, and there we go. There's 30 students in Miss Cunningham's class. All right, the next one here, the price of a sweater is reduced. Oh goodness, what does that sound? I got your shoe. No, I didn't want a shoe. I said shoe to you, like get out of here. Well, I don't wear shoes. I can see you don't wear shoes. You're a starfish. Why would you wear shoes? Well, that's what I wanted to know. Tell you what. Oh, look, a jellyfish. A jellyfish, yay! Let this be a lesson to you, children. Always go for distractions. Unless you're learning math, and then pay attention. The price of a sweater was reduced from 20 to 12. So I want to make sure I have this arrow going here to remind me 20 was what I started with, 12 was what I finished with. By what percentage was the price of the sweater reduced? Whew. Well, that's kind of a pain, right? I know it went down $8. But percents aren't dollar amounts. They're not anything amounts. They're relative amounts. In other words, if I have 50% of something, that means nothing unless I know what the something was. If I say, oh, I'm going to use 50% of the eggs. Well, that's a totally different number of eggs if I mean 50% of the eggs in my fridge or 50% of the eggs on the planet Earth. So the percentage doesn't tell me anything apart from the relationship. So here, when I say $8, I want to know, well, how is that related? And to do that, I'm going to make a fraction, and I always want to use the original as my foundation. Everything gets built on the original. So up in this problem, I started with 20. 20 is going to go on the bottom. And then the part, or the change, is going to go on top. Now, a lot of times you'll see part over whole written as the definition, and that's totally true, but it doesn't really help us remember. I guess if you remember a hole is underneath the ground, then you could, I don't know. I like to say the original is the foundation for everything. But whatever helps you remember to put that number on the bottom, go for it. The part that I'm changing, so I changed by $8. I want to know what that percent is. I don't want to know what percent of the original price is the new price. The question part doesn't say anything about new price. It's asking me to compare the price that was reduced to the original. So here I've got this, and your fraction rules are going to muddy up your mind a little bit if you're too attached to them. Normally, people who are good at fractions would right away jump and be like, okay, quick, I got to simplify. You totally could, but what does percent mean? Per, we know from earlier, means literally divide. And cent, think about money, means 100. I want to know what this is when I divide by 100. And so instead of reducing this and making it simpler, I'm going to unreduce it, complexicate it. I'm going to multiply it and make it bigger. 12 times 5 gives me 100. Fraction rules, whatever I do on the top, I've got to do on the bottom. So 12 times 5 is 100. Already, I can say this means zoop, 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 percent. So if I say that, that's the same thing as saying percent. And then look at what I get at top. I get 8 times 5, which is 40. My answer is 40%. Okay? Now, down to the next problem. We've got here where it says, the price of a video game was reduced from 60 to 45. So again, started at 60, went to 45, by what percentage was the price of this video game reduced? So, exact same question, different numbers, same exact setup. I found it! I found it! Oh goodness, Patrick, what did you find? Here, let me go show you. What is that? Patrick, is that a jellyfish? Get that out of here, it's gonna sting me! Oh, jellyfish don't sting. They eat peanut butter. No. Alright, kids. You solve this problem on your own. I am running away from this jellyfish. Good luck.